Yes, in this lecture we will be discussing modeling in STAAD Pro. Okay, so we will be using STAAD Pro software. So basic element available is your line element. So basic element is line element. Line element, it has only one dimension, that is length. So if you consider a line element, this will be called as node. So any line element will have two nodes, and this is line element, and this we will call it as length. Basic element available is line element. Line element, it has only one dimension. So for this line element we assign cross section. So cross section is only for the analysis purpose. Okay, for this line element we will assign some cross section. So cross section is only for the analysis purpose. After analysis, output will be along length. So we will get output for line element. Output will be along length. So cross section is analytically defined to it, but physically there is no cross section for this line element. Okay, so basic element is line element. So next we have area element, or we call it as plate or shell element. In ETABS, we frequently use the term shell, whereas in case of STAAD, we will use plate. It is 2D element. 2D element. So it will be like this. The bending will takes place along two directions. So these are four nodes. Okay. So for this area element, thickness will be provided. Thickness will be provided it analytically. So after analysis, outputs also in two directions. Which is along length and along width. So first type of element is line element. Second type of element is area element. So next, third type of element is solid element. Solid element. So for solid element, we will get analysis results in three directions. So solid elements are also called as 3D, three-dimensional element. So we have 1D, 2D and 3D elements. Among these three elements, 3D will take maximum amount of time. So this needs maximum time for the analysis or for the modeling purpose. The simplest is 1D. So this is the simplest element. Okay. So to create any line element, we need two nodes. You remember this one. To create any line element, we need two nodes. Okay. In the above figure, so this is node 1 and this is node 2. So to create any line element, we need two nodes. If you open STAAD Pro software, STAAD Pro 2025, first you click on this new, then go to configure. So you use language as English. Okay. Next, base unit. So you should select metric. So you have two types. One is English units and another one is metric units. So you have different see here. You have different parameters like length, force, stress, moment. Okay. You have English units and you have metric units. In case of length, if you select English, so your length will be in feet and in inches. In metric, it is meter or millimeter. Okay. So force will be in English units, it is pounds. So we will write it as LB, pounds, or kips. In case of metric units, either it may be Newton or kilonewton. So stress will be measured kips per square inches. So we will write it as KSI, kips per square inches. So here it is kilonewton meter. Sorry, not kilonewton meter. It is Newton per mm square or MPa. We use Newton per mm square. Stress, it is load divided by area. Newton per mm square or MPa. So moment in English units, moment will be kips feet or pound feet. In case of metric units, moment will be kilonewton meter. So another parameter, you have density. So in English units, density is pound per cubic feet. In metric unit it is kilonewton per meter cube. Okay, so usage, we will use English units for USA projects. USA projects. We use metric units. Metric units for India and other global projects. So this is the key difference between English and metric units. So for projects in India, we use metric units. It is compatible with IS codes and local standards. So once you open STAAD Pro, you should select metric. So this is global axis. Global axis, Y up, Y is along gravity. Next, this background and theme, it depends upon the user. Either you may go with white background or black. So I will go with white. Next, options, you keep this default options. File format, design codes. Design codes for steel, we will be using IS 800 for hot rolled steel sections. For concrete, we will be using IS 456. For aluminum and timber, we don't have any IS codes. You just keep it default. Okay. Standard profile. So default database. So here you select India. Okay. Legacy profile. So here default country. So you select Indian. Workflows, you don't change anything in this. You just keep it default settings. Okay. So units, it is in units, you should select metric. Okay, you just check one more time. Design codes IS 800, IS 456, design profile Indian, legacy profile Indian. You just click on OK. Okay. Once you made these changes, you then click this create. Okay. So first you see here, it is global axis system. Global axis system in STAAD. So if you observe carefully, it is like this. So this is X, Y is up, and this is Z. Okay. So see here, Y is along gravity, or out of plane axis. Out of plane axis. X and Z, X and Z are planar axis. Planar axis. So this is the global axis system followed by STAAD Pro. This is the global axis system followed by STAAD Pro. So whereas in case of ETABS, we have different global axis. So if you open ETABS, see here. So this is X, Z is up, okay, and this is Y. So in ETABS and SAFE and in SAP 2000, we follow this kind of global axis system because these three are developed by one company called CSI, whereas your STAAD which is developed by Bentley Systems. So this is the global axis system followed by ETABS, SAFE and SAP 2000. So here X and Y are planar. X and Y are planar. So Z is out of plane or along gravity. Okay, this is the axis system in ETABS. So I will close ETABS. So next is you need to create 6-meter beam in x-axis. So your first is you need to create 6-meter beam in x-axis. So this is the first assignment. Okay. Anyway, you know the basics. To create any line element, there should be at least 2 nodes. Okay. So this length is 6 meter. This is called as node start, or this is end, and the direction is, this is x direction. So how to create this type of beam, this type of beam in STAAD? See here. So first you open STAAD Pro, you go to geometry here, you go to geometry. See here, if this starting node is A and this end node is B, this starting node is A and this end node is B. So here coordinates are 0, 0, 0. So your direction is in x direction. So next coordinates are x is 6, y 0, z 0. So this is x, y, z. This is x, y, z. Okay, this is your node A, node B. So you open STAAD Pro. In case of geometry, you should be working in geometry. Here you have a table for nodes. Here you have a table for nodes. In this, first you type x0 0 0 0. Next, this is first node. See here, once you give the coordinates, you have a starting node. This node is A, which is 0 comma 0 comma 0 along x direction. Okay. Next, so second coordinates are 6 0 0. See here, second node is created. This is your first node A. The coordinates are 0 0 0. This is your node B, second node. So coordinates are 6 0 0. The distance between two nodes is 6 meter. Okay, how to add a beam? Okay, here there is an option. For add beam. Just you click on this add beam. You click on this first node and you click on this second node. See here, a beam is created. Okay, so this is the small assignment. Similarly, you try to create the beams of different length along different directions. So next I will take up. How to create a rectangle. Next we will see how to create a rectangle. So in STAAD, I need to create a rectangle like this. So here it is. This is your origin. So coordinates are 0 0 0. Okay, if this is 6 meter, this length, and this width is 4 meter, then this coordinate will become 6 0 0. This will become 0 0 4, and this will become 6 0 4, because this is x y z. Y is 0 because in STAAD y is along gravity. Okay, so these are the coordinates. So we will see how to create this rectangle. So once you open the STAAD, so initially you have this beam, you select this. On keyboard you press delete. Okay, so beams also gets deleted and nodes also gets deleted. So first node is 0 0 0. Second one is 6 0 0. Third one is 0 0 4. Next, fourth is 6 0 4. See, here you have 4 nodes. This is first node 0 comma 0 comma 0. This is your second node 6 comma 0 comma 0, and this is your third node 0 comma 0 comma 4, and this is your fourth node 6 comma 0 comma 4. Okay, See here, node numbers 1, 2, 3, 4. This is your first node, this is your second node, this is your third node, and this is your fourth node. So you have created 4 nodes. Then how to create the beams? Simple. You just click on this option, add beam. This option, add beam. You click on this first node to second node. Next, first node to third node, second node to fourth. Next, join these two, 3 and 4. See here, a rectangle is created. Okay. If you need to cancel any command on keyboard, you press escape. Okay. So this is how you can create your rectangle. So this is the first method. This is the first method. In the first method, what you did, you created 4 nodes. You joined those 4 nodes by using line command. Okay. So this is the first method. Okay. Now we will see the second method. Now we will see the second method. First, I will delete all these beams and nodes. You select by using cursor on keyboard, click delete, press delete. So once the beams are deleted, it will ask you to delete the nodes. You click yes. See here, nothing is there. In the nodes also, nodes table also empty. In beams table also it is empty. Okay. So first I will create first node 0, 0, 0. So here I have the first node. This is my first node, node number 1. By using this node, I will create remaining 3 nodes. So you go to select, you click on this node cursor, you select this node. Okay. You go to this node tools. Okay. You click on this copy, paste. Okay. Second node. What is the coordinates for second node? So x is 6, y is 0, z 0. Click on OK. See here, second node it is created. Okay. So 2 nodes are created. Next you go to same. To exit any command on keyboard, you click escape command. So you go to select node cursor, you select this node, go to node tools, copy, paste. So next is 0, 0, 4. Click on OK. See here, this is third one. Again you go to node tools, copy, paste. So next coordinates are 6, 0, 4. See here, all the 4 nodes are created by using copy paste command. Copy paste command. Okay. How to join these? So you go to geometry, add beam, you click on this first node, second, next, third. So this is how you can create a rectangle. Okay. So these black dots are your nodes. To hide these nodes on keyboard you press Shift K. So once you press Shift K on keyboard, so this nodes will you can hide and unhide. So Shift K. I think now it is not working. Shift K. You can hide and unhide the nodes. Okay, so this is copy paste command. Similarly, I will delete these this beams. See here I have only single beam. Here I have single beam. Similarly, you can copy paste this beam to another location. So first you select this. So go to beam tools. So you click on this copy paste. Okay. So now you select 0, 0, 4. You click on OK. See here. This beam is copied to next location. Similarly, you can draw the beam here. Similarly, you can select this beam and you go to beam tools, copy, paste. What is the opposite side node? 606. 600. You click on OK. See here. Same node is same beam is copied from this location to this location. This is copy paste command for nodes and line elements. Okay. So now I will delete all these beams. I will delete this beam also. I will create a node 0, 0, 0. I have created one single node. There is a option called translational repeat. Instead, there is an option called translational repeat. So in geometry, it is located here. So once you click on this translational repeat, so you select global direction, on what direction you need node. Okay, number of steps, let it be 1. And you default spacing, you give 6. You click on OK. So please select member nodes. Okay. First I have to select this node. So you go to select node cursor. You select this node. If the node is in red color, means it is selected. Now you click on this. Okay. See here. So this is your first node, and I have created the second node by using translational repeat command. Okay. So to get the node coordinates, you double click on any node. If this is your node, you just double click. So you go to select node cursor, you double click. See here, it is showing its coordinates x0, y0, z0. You just close. Similarly, you click on this node. See here, your coordinates are x6, y0, z0. Okay, so double click on any node to get coordinates. So next step is, suppose I have 3 nodes. I will delete these nodes. Suppose now I have first node here. This is my first node. This is my second node. And this is my third node. And node 1 to node 2 is distance 4 meter. Node 2 to 3 distance is 5 meter along x direction. Along x direction. So first you create this node. So this is 0, 0, 0. So I will create first node 0, 0, 0. So this is my first node. Next node is, next I will use a translational repeat. Next I will use translational repeat. See here, you go to geometry. You click on this translational repeat. See, in global direction, it should be x. So number of steps here. So this is step 1. So node 1 to 2 is step 1. Node 2 to 3 is step 2. So you have 2 steps. So first you select the member or joint. Where is the node? I have created 0, 0. See here, this is your first node. You first select this joint. number of steps 2. So first step is 4 meter, second step is 5 meter. You click on OK. See here, it is created 3 nodes. This is first node, this is second node, and this is third node. So distance between 1 and 2 is 4 meter. Distance between 2 and 3 is 5 meter. Okay, this is along x direction. So similarly, I will create so remember here it is x, y is up, this is z. Similarly, I will create 3 nodes here. Okay, this along z direction, distance is 4 meter. Distance is 4 meter. So for which first you select these 3 nodes. First you select 1, 2, 3 nodes. You go to translational repeat. Now it is required in Z. In what direction? Z direction. Number of steps. You have only one step. So you have only one step, 4 meter. So step spacing, default step spacing is 4 meter. So you click on OK. See here. So next nodes are created here. I will erase this. Initially, I created these 3 nodes by using translational repeat along Z direction. I created these 3 nodes at a distance of 4 meter. Okay. Okay, next I will delete all nodes. So you go to select node cursor, select all these 6 nodes. On keyboard you press delete. Okay, I will create starting node 0, 0, 0. I will create first node. This is my first node. So now I'll demonstrate translational repeat command with link steps. Okay, so first you select this node, see here it is showing red, which means your node is selected. So first you select this node, you go to geometry, translational repeat. See here, you give any spacing 5 along x direction. You click on this link steps. You click on OK. See here, So if you select link steps, if you select the link steps, it will joins the node by element. So this is 0 0 0, this is 5 comma 0 comma 0. If you select link steps, these two nodes are joined by using line element, automatically joined by using line element. So this is the option called link steps. Okay, so we will take up a small assignment. So I need to create a plan like this. See here, this is 3 meter, 4 meter, 6 meter, 6 meters, and this is your distance 6 meters, and this distance is 3 meter, and this will be 3 meter. This distance is 1.5 meter, and this is 3 meter, and this is 1.5 meters. Okay, so this is your origin. This is your origin. So here it is x0, z0. So along x direction, you need to create a plan like this. If you see it from this direction, so this is x, y will be along gravity, so z will be like this, y will be along gravity direction. Okay, so if I term this as a, so elevation is, in elevation it will look like this. So initial 2 meter, so this is level 1. Next 3 meter, it is level 2, and this is level 3, which is also at 3 meter, and this is also 3 meter. So this width is, if you see from this direction, this width is 6 meter. So this is your plan, and this is your elevation. Okay, so this location y equals 0. So this is your y direction. positive y direction. Okay, so how many steps you have? See here. Here you have, this will be called as step 1. Step 1, from here to here, it is step 2. From here to here, it is step 3. From here to here, it is step 4. Okay, you have 4 steps. So distances are 3, 4, 6, 6. Okay, so you go to STAAD, you delete everything. You delete your past model. Okay, in first you go to geometry, you create first node, origin 0, 0, 0. So this is your first node. You go to select node cursor, you select this node, you go to geometry, you click on this translational repeat, you need along x direction. So how many steps you have? You have step 1, step 2, 3, 4. 4 steps. Distances are 3, 4, 6, 6. So number of steps, you type 4. Oh, sorry. So you select this node, go to geometry, translational repeat, number of steps 4. Don't press enter. Okay. So first spacing is 3 meter. Second, as per your drawing, second is 4. Third is 6. 6. Fourth spacing is 6. See here. First step 3, 4, 6, 6 along x direction. See here. Along it is x direction. Okay. You click on this link steps. You click on this link steps. You click on OK. See here. See here. This part of the drawing, this line, it is created. So you go to STAAD. So this is your origin 0, 0, 0. This is your step 1, step 2, step 3, step 4. So this distance is 3 meter. This is 4 meter. This is 6 meter. And this is 6 meter. Okay. Now I have created this line. I will copy this segment to here. Along what direction? Z direction. Distance is 6 meters. So you go to STAAD. You go to select. You select beam cursor also. You select all the beams. You go to geometry, translational repeat, along Z direction. Default steps is one step. along Z direction you need one step, distance is 6 meter. So if I click link steps, so this is 6 meter distance. You click on this link steps, you click on OK. See here, by using translational repeat command, I copied this beam to this location with link steps, which means combining these nodes. If you don't select the link steps, you won't get these 4 beams, 3, 4, 5 beams. Okay. Okay. So you need intermediate beams. Now you need to create this beam, this beam, this beam. So 1.5, 1.5, this is 3 meters. You copy this plan and elevation, then it will be easy for you to model. So first I will complete this one. So you go to STAAD, you select this node. At what distance? 3 meter. You go to translational repeat, along Z direction, default spacing 3. Okay, you click on OK. See here, a beam is created at a distance of 3 meter. Next you select this beam, distance is 1.5. You go to translational repeat, along Z direction, so it is 1.5. You click on OK. See here, this beam is created. So next you select So once you create this beam, next distance is 3 meter. So you go to STAAD, you select this beam, go to translational repeat, Z direction, distance is 3 meter. You click on OK. See here. So earlier it was single beam. From here to here it was a single beam. When we model our intermediate beams, beams gets divided. See here. So automatically your beam gets divided. So this will be one part, this will be second part, this will be third, and this will be fourth part. If you see here, see. So this is first, second, third, fourth. So beams is automatically divided. So here also see here. Initially it was a straight single beam. Once you model this intermediate beam, this beam gets divided. See here, this is one beam and this is another beam. Okay. Now you select this. Now select all the beams. You go to translational repeat. Now it is in Y direction. See here, you need to create elevation Y direction. So number of steps 1, 2, 3. See here, this is step 1, step 2, step 3. Okay, so distances are 3 meter, 3 meter, 3 meter. So default spacing 3 meter. default spacing 3 meter, y direction, number of steps you select 3. Again you click on this link steps, you click on this link steps, you click on OK. See here, if you observe this plan, so I forgot to mention the column locations. I forgot to mention the column locations. So these are your column locations. So these are your column locations. If you observe your STAAD model, if you go back to STAAD, it is created column here, and here also it is created a column. Simply here also it is created a column, but it is not required according to plan. It is created a column here. For as per my plan, these columns are not required. I have columns only at the periphery. Here I have the column, here, 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 here I have the column. Similarly here I have at the red locations. I don't need any columns. So you need to carefully select those elements. So first you select one beam, you use control option on keyboard. Okay, next you select this, you select this. You should be careful while selecting those elements. You select these columns or line elements. Okay, once you select the correct elements on keyboard, you click delete, press delete. See here, so all the columns are gets deleted. Okay, so it is how we can remove unwanted columns. Okay, so you go to view. So this is, you go to view options. So this is isometric view, and this is top view, this is bottom view. So these are side views. So these are side views. So till now we created this part. Again I need to create this level. So this is y0, this level is y0. Okay, and this level is -2, because this is positive y direction and this is negative y direction. So this level is -2. Okay, so you go to STAAD, you go to select node cursor, you click on this first node, use control button on keyboard, second, third, fourth, fifth, sixth, 7, 8, 9, 10. So I have selected 10 nodes, which means 10 column points. So what I have selected? I have selected this column position, column location 1, 2, 3, 3. This is 4, 5, 6, 7, 8, 9, 10. I have selected these nodes. You go to start. Okay. So you go to geometry, translational repeat. So along y direction, default steps 1, you need only one step. Default step spacing, it is -2, because below the ground level or below the level of y0. You click on this link steps. You click on this link steps. You click on OK. See here. Now it is created the lower level. So this part also completed. Okay. So to see the global axis. So to see the global axis system, so on keyboard there is a shortcut called Shift I. So you click on Shift I. See here. Here you will get your global axis system. So X, Z, X and Z are planar, Y is along gravity. Okay. So global axis system. Shortcut is Shift I. So on keyboard you just press Shift I. Shift I. So once you press Shift I, it will appear. If you press the same Shift I, it will disappear. Okay. So this is the shortcut for global axis system. Similarly, there is a shortcut command for local axis system. There is a keyboard shortcut command for local axis system. So keyboard shortcut command is Shift O. So on keyboard you press Shift O. See here. These are your local axis. These are your local axis. So again, if you again press Shift O, it will disappear. Okay. So this is how you can create a model in your In STAAD Pro software. So similarly, you practice your assignment questions. Okay.